Hello, my name is Shubhendu Das and I am your mathematics teacher at Minata. And today I am going to teach you one of the most important topic of class 10. It will be linear equation in two variables. We have already completed 7 lectures in this topic. So today we will start lecture number 8 with the conditions for solvability of linear equations. That means how we can check it is solvable or not. We will read this one. Now, there are three conditions. The first condition, if the system of linear equation has a system of pair of linear equations are there, mm, linear equation is given. System of pair of linear equations that is a1x plus b1y plus c1 will be equals to 0 and a2x plus b2y plus c2 is equals to 0. Two equations are there. Now the first condition, if it has unique solution, how we can check? There is a condition to check there's a if it is has unique solution or not. The condition is that a1 by a2 is not equals to b1 by b2. That means the coefficient of x in the first equation divided by the coefficient of x in the second equation will not equals to the coefficient of y in the first equation divided by coefficient of y in the second equation. If it is a unique solution, it will be not equal. Now if it has infinitely many solutions, what is the condition to become the infinitely many solution? That will be a1 by a2 is equals to b1 by b2 is equals to c1 by c2. That means the coefficient of x in the first equation, coefficient of x in the second equation, the ratio will be equals to coefficient of y in the first equation, coefficient of y in the second equation, and it is also equals to the constant in the first equation and the ratio of constant in the second equation. Now the third condition, if it has no solution, if it has no solution, how we can check it has no solution? If a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2. So this is the way to find if it is a unique solution. That means a1 by a2 not equals to b1 by b2. Infinitely many solution, a1 by a2, b1 by b2 and c1 by c2 should be equal. But if it has no solution, a1 by a2 equals to b1 by b2, but it is not equals to c1 by c2. If it is fulfilled, then these conditions fulfilled, then we can say it has unique solution, or it has infinitely many solution, or it has no solution. Now we'll move to the example. So first example number 1, if it is given this system of equations are given. The first equation, 2x plus 5y is equals to 17, and the second equation, 5x plus 3y is equals to 14. Now we have to check that if it has infinitely many solutions, then what will happen. Let's check. And it has infinitely many solutions. And if it has infinitely many solutions, that means here a1x, that means a1 is 2, b1 is equals to 5, and c1 is minus 17, because we can write this in this way also. You can write 2x plus 5y minus 17 becomes 0, and you can write this one as 5x plus 3y minus 14 will be equals to 0. Now c1 is here minus 17. Now if you check what is a2, a2 is 5. What is b2, b2 is 3. And what is c2, c2 is minus 14. Now check in this form, that is infinitely many solution. That means a1 by a2, it should be equals to b1 by b2, it should be equals to c1 by c2. We have to check it has infinitely many solution or not. So a1 is 2, 2 by 5, b1 is 5 by 3, that means it is not equal. Okay, c1 by c2, it is minus 17 by minus 14, that is also not equal. So that means we can say that a1 by a2 is not equals to b1 by b2. That means it is not has infinitely many solution. That means it, what is the condition of a1 by a2 is not equals to b1 by b2? That means when it has unique solution. So this has unique solution. Okay, it has unique solution. Okay, let's do the next one. Question number 2. Find the value of k for which the system of equations that is x minus 2y equals to 3 and 3x plus ky is equals to 1 has a unique solution. It has a unique solution. Okay, so how we can solve? It's very easy. First you have to write in the form of a1x plus b1y plus c1. We have to write in the form a1x plus b1y plus c1 will be 0, and the second equation, that is a2x plus b2y plus c2 will be equals to 0. Now if you write this equation in this form, so we can write x minus 2y minus 3 is 0, and from second 3x plus ky minus 1 will be equals to 0. Now check what is the value of a1. a1x is equals to x. That means a1 is 1, b1 is minus 2, and c1 is minus 3. Now check here, a2 is 3, b2 is a coefficient of y, that is k, and c2 is minus 1. And it is said that it has unique solution. So the unique solution, we know that for unique solution, it must be, we must have but a1 by a2 not equals to b1 by b2. Now what is a1? 1, a2 is 3, not equals to minus 2, b2 is k. So it is not equals. So that means here we can say that k is not equals to minus 6. That means the given system of equation, if x is not equals to minus 6, then it has unique solution. That means the given system of equation will have a unique solution for all real numbers except minus 6. Or all real values, you can say. So instead of numbers, you can write real values of k other than minus 6. माइनस 6 को छोड़ के k का वैल्यू कोई भी हो सकता है. Then we can say it is has this the system of equation has unique solution. As we know that first we have to write in the form a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. Now convert this in this form. So we can say x minus 2y minus 3 is 0, 3x plus ky minus 1 is 0. So a1 is 1, b1 is minus 2, and c1 is minus 3. Now a2 is 3, b2 is k, c2 is minus 1. So for unique solution, we must have a1 by a2 not equals to b1 by b2. That means 1 by 3 not equals to minus 2 by k. K is equal not equals to minus 6. That means other than minus 6, all real values should be possible. Now coming to the example number 3. In the example number 3, it is given that so that the system of equation system of equations are 4x plus 6y is equals to 7, and 12x plus 18y is equals to 21 has infinitely many solutions. Let's check. We need to check this one. So here you have to write in this form a1x plus b1y plus c1 is equals to 0. So we have to write a1x plus b1y plus c1 equals to 0, and we have to write a2x plus b2y plus c2 will be equals to 0. Now we can write 4x plus 6y minus 7 is equals to 0, 12x plus 18y minus 21 is equals to 0. So now here a1 is equals to 4, b1 is equals to 6, and c1 is equals to minus 7. Now here a1 is 12, b1 is 18, and sorry, a2 a2 is 12, b2 is 18 in second equation, so c2 is minus 21. Now let's check what is the value of a1 by a2. That will be 4 by 12, that means 1 by 3. Now what is b1 by b2? 6 by 18, that means it is also 1 by 3. Now c1 by c2, it is minus 7 by minus 21, that is 1 by 3 also. So here we can say that a1 by a2 is 1 by 3, and b1 by b2 is also 1 by 3, and c1 by c2 is also 1 by 3. That means a1 by a2, b1 by b2, and c1 by c2 is equal. And we know if it is actually happens, that means the system equation has infinitely many solutions, because this is the condition to become the infinitely many solution. That means, as you can say, the given system of equation has infinitely many solutions. Okay, so what is given? You have to show that the two given system of equations are there. 4x plus 6y is 7, 12x plus 8y is equals to 21. So it has infinitely many solutions. You have to show that. Okay, first you have to write in this form: a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. So here just you have to convert this way: 4x plus 6y minus 7 is 0, 12x plus 8y minus 21 is 0. So a1 is 4, b1 is 6, c1 is minus 7, a2 is 12, b2 is 18, and c2 is minus 21. Now what is the value of a1 by a2? It's 4 by 12, means 1 by 3. b1 by b2, 6 by 18, means 1 by 3. And c1 by c2, minus 7 by 20 minus 21, that is also 1 by 3. That means we can say that a1 by a2, b1 by b2, and c1 by c2 are equal. So it is only possible when it has infinitely many solutions. Now example number 4. Find the value of k for which the following pair of linear equations has infinitely many solutions. So here the equations are given: 2x minus 3y is equals to 7, and k plus 1 into x plus 1 minus 2k into y is equals to 5k minus 4. First you have to write in this way: a1x plus b1y plus c1 is equals to 0. So here 2x minus 3y minus 7 is equals to 0, and this second equation, a2x plus b2y plus c2 is equals to 0. So k plus 1 into x plus 1 minus 2k into y minus 5k minus 4 is equals to 0. Now here if you compare, you will get a1 is 2, b1 is minus 3, and c1 is minus 7. Now a2 is k plus 1, b2 is 1 minus 2k, and c2 is minus of 4, 5k minus 4. That means we can say 4 plus 4 minus 5k. So it will be minus of this. That means minus 5k plus 4. So 4 minus 5k. That's it. Now it has infinitely many solutions, as it has infinitely many solutions. That means we can say that a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Now just put the value, that is a1 is 2, b1 is k plus 1, b1 is minus 3, b2 is 1 minus 2k is equals to c1, that is minus 7 by 4 minus 5k. Is that equal? Now here we can say that means 2 by k plus 1 is equals to 3 by, if you take minus common, so it will be 2k minus 1 is equals to 7 by 5k minus 4. These are equal. Now first we can say that 2 by k plus 1 is equals to 3 by 2k minus 1. This is first. And the second we can say 3 by 2k minus 1 is equals to 7 by 5k minus 4. Now here 4k cross multiply 4k minus 2 is equals to 3k plus 3. So 4k minus 3k, that means k is equals to 3 plus 2, that is 5. Now check here as well, that is 15k minus 12 is equals to 14k minus 7. So 15k minus 14k, k is equals to minus 7 plus 12, that means 5. So k is also 5. So from both the equation you can get that the value of k is 5. So here we can say if the value of k is 5 and in this given system of equation has infinitely many solutions. Now just revise this one. What is given? The find the value of k for which the following pair of linear equation has infinitely many solutions. So first equation 2x minus 3y is 7. Second equation k plus 1 into x plus 1 minus 2k into y equals to 5k minus 4. So first you have to write in this form a1x plus b1y plus c1 is equals to 0. If you write, you get a1 is equals to 2, b1 is minus 3 and c1 is minus 7. Now write this second equation. If it is equation number 1 and this is equation number 2, you can write in this form a2x plus b2y plus c2 is equals to 0. If you write, you get by comparison a2 is k plus 1, b2 is 1 minus 2k and c2 is 4 minus 5k. So it has infinitely many solutions. That means a1 by a2 equals to b1 by b2 is equals to c1 by c2. Now what is a1 here? 2 by k plus 1. What is b1? A1 is 2 and a2 is k plus 1. Now b1 is minus 3, b2 is 1 minus 2k and c1 is minus 7, c2 is 4 minus 5k. Now if you check, you will get 2 by k plus 1 equals to 3 by 2k minus 1 is equals to 7 by 5k minus 4. Now first compare first these two and then let's check another. Okay, 2 by k plus 1 is equals to 3 by 2k minus 1. First comparing these two, you will get k is equals to 5, and from the second and third, 3 by 2k minus 1 equals to 7 by 5k minus 4. If you cross multiply, you will get k is equals to 5 also. So here you get that k is equals to 5. So in today's class, we learn very important things. That is, if the system of pair of linear equation are there, first condition, if it has unique solution. If it has unique solution, that means it must be, if the equation in this form a1x plus b1y plus c1 is 0 and a2x plus b2y plus c2 is equals to 0, then it has unique solution if a1 by a2 not equals to b1 by b2. And same, if infinitely many solutions are there, then the condition should be a1 by a2 equals to b1 by b2, and it is also equals to c1 by c2. And the third condition, if it has no solution, the condition only fulfill if a1 by a2 and b1 by b2 is equal, but it is not equals to c1 by c2. So today we learn very important things. So this is a very important things. So you have to keep in mind forever. So most important thing, we have to copy this one, most important. So three condition, if it has unique solution, if it has infinitely many solution, and the third, if it has no solution. These are the conditions. This is the first criteria, this is the second criteria, and this is the third criteria. I hope you enjoyed the session, and I hope all the doubts are clear. Thank you for joining the session. I will continue this session in the next class. The same topic will continue in lecture number 9 as well. Thank you for joining the session.